Okay, so for this video, we're going to revise how to solve quadratic equations. There are three main ways we're going to solve quadratic equations. There are others that take a lot longer, but these are the three main ones we're going to look at, and these are the three ones we've been looking at since year 10, pretty much. Year 10 maths, that is. So we got the null factor law approach. Remember, for the null factor law approach to work, you must factor first. Must be able to factorize your expressions. If you can't factorize, don't bother, because null being 0, but factors. The whole point is a factor. And the null factor law, remember, says if two things multiply to give you 0, then A equals 0 or B equals 0. Of course, this can be extended out to being A times B times C equals 0, then A, B, or C must be 0. Isolating x, this can only occur if there is no x term. No single x term by itself. So that'd be something like x squared take 2. You couldn't have x squared minus 2x, that would not work. X squared minus 2 would work with this. And you also need to have a negative, or at least opposite sign. You can have a positive x squared there and a negative 2, or you can have a negative x squared and a positive 2. But if both signs are the same, both positives or both negatives, you would not be able to solve an equation in this way, unless you are doing complex numbers, which we are not doing in this course. And the last one is quadratic formula, and this will always work as long as you use it correctly. Of course, I'm assuming no simple mistakes, but it will always work as long as you use it correctly. But it's a bit over the top. For a really straightforward thing to factorize, it would be much more useful and waste a lot less time to factor it. So it's a bit like using a sledgehammer instead of a standard hammer to put a nail in or something. It'll work, but likely to do more harm than good in the long run. So for methods 1 and 3 to work, you need to have a 0 on one side. For method 2 to work, it actually doesn't matter, and you'll see how that works out in a minute. So solve each of the following problems. The first one, before I choose which method to use, I'm going to have a look closely at the values I got. Can I easily factorize it? Now look at the factorizing video to remind yourself how to factorize quadratics. In this case, I can easily see that that'll give me x plus 9, x plus 1 equals 0. Make sure you have all your equal signs in the right spots and you've got your notation there correctly. And then to solve that, we know x plus 9 must be equal to 0, which therefore gives you negative 9. And x plus 1 is 0, which gives you negative 1. And that's using your null factor law. So factorize and solve. This next one, I can clearly see it's not going to be method 2 because there's an x term. We don't want the x terms to use method 2. So it has to be quadratic formula or null factor law. But in both cases, I need to have a 0 on one side. So I'm going to subtract the x and add the 14. So this is going to move across, and you're going to end up with 2x squared minus 16x plus 24 equals 0. There's a common factor of 2, so I'm going to divide through by that common factor. Minus 8x plus 12 equals 0. Now, I can use quadratic formula if I want, but I'm going to first check and see if I can factorize it. So are there factors of 12 that add to negative 8? Yes, there are. That is x minus 2 and x minus 6. The factors are negative 6 and negative 2 that multiply 12 that add to negative 8. And that will therefore give me x equals 2 and x equals 6 by the null factor law. Remember, you put each bracket individually equal to 0. That's always really straightforward when there's only a single term there. When you've got a 2 or something in front of the x, it's a little trickier, but just follow a simple linear equation, you'll be fine. Don't make simple mistakes. This next one, in this case here, we've got a bracket squared, so the quadratic formula will not work. In this case, it needs to be fully expanded with a 0. So I could actually factorize this, or I can use the isolating x method. Now, in the isolating x method, I said you cannot have an x term, and you can see in here there's a single x, but notice it's x minus 1 all squared. So we treat this whole thing as a single term. And you got a minus 8. So in this case, I can factorize or isolate x. Isolate x will be quicker, but because to factorize, I have to come a factor of 2 out first, and then I'm going to apply dots to that. However, because I'm solving, I can just take the 8 across, or move the 8 across by adding it, divide by 2, and then get rid of the square root by, so the square by square rooting the 4. Don't forget square root of 4, because we're squared here and that we're undoing it, it's plus or minus, not 4, but plus or minus 2, sorry. And then we're going to add 1 across. So you're going to have negative 2 plus 1 gives you negative 1, or 2 plus 1 is 3. Please don't leave your answer as plus or minus 2 plus 1. If you had a square root, that makes sense. You'd have to leave it as just 1 plus or minus root 2. But if you have a number there, make sure, like a rational number that you can add together, make sure you do it. Next one, there's no x term here. So it's a prime candidate to do isolating x. I can actually do quadratic formula. In here, just b will be 0 in a quadratic formula. And I could do factorizing. This is dots. If you factorize this, it would be dots. You would get 2x minus 3, 2x plus 3. But again, go back to the factorizing video to remind yourself. But this case, I always feel that when you've got x squared, a number, much easier to isolate x. We divide by 4, and now we find the square root. So that's plus or minus the square root of 9, which is 3, over the square root of 4, which is 2. So you can hopefully see that picking the correct method makes your life a lot easier. This top one here would have taken a long time with quadratic formula, but really quick with factorizing. This one here is fraught with danger factorizing if you forget to square root the 4, or if you just forget how to use dots properly or whatever, but nice and quick with isolating x. All right, this last one here, first thing I want to check is isolating x. No, there's an x term there, and the last one over here is not going to work either with isolating x, unless I complete the square first. And if I can avoid completing the square, I do so. Next thing, can I factorize it? Well, 5 times negative 2 is negative 10. Are there any factors of negative 10 that add to 1? I don't think so, because 5 and negative 2, or negative 5 and 2 are factors. They don't add to 1, and neither is 10 and negative 1. So we're going to have to use quadratic formula here. Again, I could use completing the square and then isolate x, but that's going to take way longer than I need to. So I'm going to use x equals negative b plus or minus the square root of b squared minus 4ac. Remember the b squared minus 4ac thing, that is our discriminant. And you can sort of work that out on the side if we want. Let's just remind ourselves that there is a discriminant. Go check out the discriminant video that I've already made to help you with that. So b is the coefficient of x, which is 1. So negative of 1 plus or minus square root, well, b squared is 1 squared minus 4 times a, which is 5, times c, which is negative 2. By the way, I should have checked to make sure the discriminant was indeed non-zero before I started, but I guess because I wrote the examples out, I knew that would be the case. And we divide by 2 lots of a. And then we simplify. So plus or minus, get 1. 4 times 5 is 20, times 2 is 40. There's 2 negatives multiplying, which makes it positive, and then we add the 1. So we get square root 41 over 2 times 5, which is 10. This case, I cannot simplify the square root any further. 41 is a prime number, so you can just leave it like that. If this square root came out to a nice whole number, which is what it will do in any of these top cases up here that we've done so far, it'll come out being a whole number, then you would have to split it and do negative 1 plus and simplify that, negative 1 minus and simplify that. This last one over here, not isolating x, can I factorize it? Well, negative 3 times 4 is negative 12. Are there factors of negative 12 that add to negative 2? I can't think of any straight away. 4 and 3 give you 12, but the difference is not 2. 6 times 2 doesn't work, so I'm going to go quadratic formula again. I knew this would be quadratic formula anyway because I wrote it, but it's taking you through the thought processes. Right, so we get negative of -2 plus and minus the square root of -2 squared minus 4 times a, which is -3, times b of times c, sorry, of 4. That is all over 2 times -3. Now, negative of -2 is +2, plus and minus. You get over here, this little section down the end, that simplifies into 4 times 4, which is 16, times 3 is 48. So it's plus 48. We can do 4 times 3 is 12, times 4 is 48. 2 negatives multiplying gives you a positive. So this is 4 plus 48, which gives you square root of 52 over -6. Now I don't want the negative down there, so I'm going to divide the terms up the top by negative. So you have -2 plus or minus or plus, technically they switch over. So minus or plus, because positive divided by negative, and a negative divided by positive. Now root 52, I must simplify that, do not forget. So 52 is 4 times 13, which is 2 root 13. Like that, over 6, and then we find a common factor that I'm going to divide. It only works if it's a factor of both of these, in which case it is. So that gives you -1 plus, or minus or plus, root 13 over 3. I could leave it as plus or minus in this case. It doesn't matter in this particular case, but it can if you've got other things tacked on the end, which is why I did flip the signs when I divided by a -1 from there. Don't forget that this can be written separately as -1 over 3 minus plus root 13 over 3. You do not have to write like that, but don't forget that's the case because that will enable you to locate intercepts. It will enable you to recognize, oh, I have to simplify further and those sort of things. But for now, that is how you solve quadratic equations.